scientific method, you guys have learned throughout time eternal what the scientific method is. You've always had to memorize the steps. And I don't want you to memorize the steps. I just want you to realize that what you've been doing every day making decisions is in fact the scientific method. Think about it. In the beginning, what do? Identify a question. I'm hungry. That's a question, right? That's a problem. I'm hungry. What will make me not hungry anymore? That becomes the question. Then you formulate a hypothesis. Now, you don't think that you're doing it, but you do. You go to the refrigerator and you say, I wonder if eating a slice of zucchini will make me not hungry anymore. That's your hypothesis. Can you test that? Because that's what a hypothesis is. And so you get a slice of zucchini, you eat it. It's quite delicious and healthy, I'm sure. And at the end of it, you've collected your data. You know what you feel like. You know what it tasted like. And you go back and you say, okay, was my hypothesis true? And your hypothesis was that the slice will make you not hungry anymore. And you can either identify, yes, your hypothesis was right, or no, my hypothesis was wrong. If your hypothesis is wrong, what do you do? You ask another question. So you go back to the refrigerator and you look in there and you say, look, there's 3 slices of leftover pizza. Well, 3 slices of leftover pizza make it so I'm not hungry anymore. Well, of course they will. All right, good. Once you know that's true, then you've proven your hypothesis and then you go on. Whether it's identifying a problem, coming up with a question, designing an experiment to test the question, collecting data, reaching conclusions, all those are all part of the scientific method. You guys really do that every day in class. And so it's just kind of a straightforward thing of what is the scientific method. A hypothesis is just a testable idea. So a lot of people might say, well, my hypothesis is that aliens built the pyramids. Well, how can you test that, right? How can you test that? My hypothesis is that God created the world. Well, that's not really a hypothesis so much as that's your belief. And there's a difference there. My hypothesis is that love makes the world go round. Well, I'm pretty sure it's not love is what makes the world spin. And even if you thought that was a hypothesis, how would you test it? If you say my hypothesis is that if I stop putting gasoline in my car, I believe it will stop running, well, that's testable. You put some gas in your car, you let it go, you leave the gas out of your car, you start it up, try to see what happens. It's something you can test. It's something you can measure. A theory is when you've run a hypothesis lots of times and you've got a lot of data showing it, you have a very strong theory. Theories are never absolute. The theory of evolution is a good example. The theory of evolution says that things change over time, and we have a lot of data to back that up. Now, can that theory of evolution change a little bit? Of course it can. If we make new discoveries, if we make new findings, then we will see those discoveries come to light, and then you're like, oh, okay, now we have to modify our theory a little bit. And I'll actually show y'all a video of a guy named Jack Horner and dinosaurs, and we'll watch that video. Just remind me to pull it up. And it's not very long, but it kind of brings you into the idea that science is never ending. Okay? Theories are always remain theories. They never become laws. Theories can get stronger based on data, or they can be proven wrong based on other data. Theories never become laws. A law is like the law of gravity. When you drop something, it falls. I'm not explaining why. I'm not giving you a reason. I'm just stating what is true. So we don't really have that many laws in science. The law of conservation of mass. You can't make matter or destroy matter. Why not? I don't know. It just, that's the way it is, right? So that's the difference between hypothesis, theory, and law.
I get it. I understand your frustration. We're all searching for ultimate #truth, and complex, challenging ideas don't always fit nice and neatly in our brains. But what is truth? Are there different levels of truth? Are some truths truthier than others? Well, I don't know, but I do know this. Science is the absolute best tool we have for understanding how the universe works, and theory is not a 4-letter word. If we're gonna trust science together, the least we can do is speak the same language. Words like fact, Theory, hypothesis, and law mean something totally different to a scientist than the way they're used in everyday speech. So let's get them straight. Facts are really just observations about the world around us, and we observe things every day, like that it's bright outside when I look out the window. And we often develop explanations for those observations, like, okay, the sun is probably up. Congrats! We just developed a hypothesis. But a hypothesis isn't something you prove. It's something you test. So, let's walk outside. It's bright, the sun is up, hypothesis confirmed. Way to go! We did a science. We often come up with multiple hypotheses to explain an observation. We just eliminate the ones that are wrong. What's left over is not a theory or a law or an ultimate truth. It's just a possible explanation for something, one that can lead us to new hypotheses, which may agree or disagree with the original one. It's a never-ending story, only without the big fluffy dragons.
That's so good.
When enough hypotheses have gotten the old scientific check mark, we can pile these all up and turn them into something greater, a theory. A theory is the way we know something works, based on the evidence we've collected and all the hypotheses that we've successfully put to the test. The best thing about a theory is that we can use it to make predictions, and not just about the way things are, but how they will be. You may have heard someone say something like, I have a theory about why cats purr. I think it's because they're actually tiny robots, and those are their gears. Well, that's not a theory. That's actually a hypothesis. It's something that could be tested, but don't try this at home. This cycle, taking facts and observations, thinking up possible explanations, testing those explanations, and then making predictions based upon them, that's what this whole science thing is about. Being a theory isn't a bad thing. It means that idea got the gold star, the blue ribbon, a big shiny trophy that says, countless experiments have shown that I am sufficient to explain all the observations that I encompass. Now, to see if you got this down, let's look at some examples. Fact, people get sick. I think we can all accept that. Hypothesis, people get sick because something gets in their body and starts doing bad things. Test each hypothesis, throw out the bad ones, and we're left with a framework that lets us understand why we get sick and make predictions. The germ theory of disease. Okay, let's try another. Evolution is a fact. We know that it happens, no doubt. But how does it happen? Evolution by natural selection is a theory. We've come up with thousands and thousands of hypotheses about it, tested them, thrown out the bad ones, and we developed a pretty darn good framework for predicting how living things change over time. So yeah, it's a theory. Stop saying it like a bad thing. Calling it a theory means it's passed the toughest tests that we can throw at it. And evolution has been tested maybe more than any other theory we know of. We should really call it the theory of the fact of evolution. What about something as fundamental as gravity? Is that a theory or is it a law? In science, a law is a detailed description, usually using math, of how something happens, like the movement of gas molecules related to temperature, or how mass and energy are always conserved. But a law doesn't tell us why something happens. Gravity, as it turns out, is a law and a theory. Newton's law of universal gravitation describes precisely how two objects will attract each other based on their masses and the distance between them, and gives us a nice formula we can use to figure it out. Textbook law. But Newton's equation doesn't describe what is happening or why. To do that, we need a theory of gravity. Fact, if I drop this, it'll fall. Law, I can mathematically describe how fast that apple and the earth will accelerate toward one another based on their masses and distance. But why is it happening? Hypothesis. There's a force pulling on the apple, or maybe there's something about the universe and the way it's structured that makes massive things fall toward one another. Or maybe the apple is like magnetically attracted to Earth or something. Eliminate the bad ones and we're left with a theory. And thanks to Einstein, we've got a theory of gravity called general relativity. But once scientists stumbled upon quantum mechanics, they began to realize that Einstein's relativity didn't account for what was happening on the very smallest gravitational scales in the universe. General relativity is still great at describing the universe at the scale that we interact with it. But even the theory of gravity is incomplete. Does that mean we throw it out because it can't explain everything? No, I mean, if you get a flat tire on your car, you get a new car. If you change the tire, is your car a different car all of a sudden? All of these fit together to make the scientific machine. We're constantly adding and taking away parts, but it keeps on running just fine. It just means we've got more work to do to make Einstein's theory even more right. Science is never done. It's always changing, and this bothers some people. How can we trust it? How can something be strong and robust if it could be different tomorrow? The goal of science is to devise frameworks that describe how things work, to truly understand why things are the way they are right now, so that we can know how things will be in the future. And if we can learn to trust science in all of its fuzziness and incompleteness, I predict that future is going to be very bright. I like that theory. Stay curious.